Calculating landing velocity. To calculate landing velocity, let's zoom in on the object as it lands. The landing velocity is a vector on an angle composed of x and y components. It's the hypotenuse of a right triangle. We will find this hypotenuse using the Pythagorean theorem. Vx, so the velocity in the x dimension, stays constant the entire flight. However, the velocity in the y dimension will be changing throughout the flight. So we need to use either kinematics equation 1 or 3 to figure out the velocity, the landing velocity in the y dimension. Then we'll use the Pythagorean theorem to calculate the length and the direction of the hypotenuse. For projectile motion type 1, there's no initial velocity in the y dimension. It will gain speed vertically at the same rate as an object dropped from the same height. So here's our cliff, and we're launching a ball off horizontally. It's going to go like this, and it's going to land with a certain y component of velocity. However, if you took that ball and you just dropped it, it would also land with that same amount of velocity in the y dimension. So how can we calculate how fast an object is moving after being dropped from rest from 30 meters up? In the y dimension, we know that the initial velocity is 0. We know how far it falls, 30 meters. And we know acceleration is negative 9.8 since this is an object in free fall. So we can solve this for the final velocity in the y dimension, which is negative 17. So here, look, we have that v squared is 294. We have to take the square root. Now you have to remember that this is negative velocity since that vector is pointing down in the same direction as acceleration. So if acceleration is negative, so is this vector. They're both pointing down. Therefore, we have a right triangle. This component is 50 units long. This component is negative 17 units long. Keep in mind, these are not to scale, obviously, because 50 is more than twice 17, but this image is not to scale. All right, so what's the length of the hypotenuse? C squared equals A squared plus B squared. Plug in 50 and 17, and we see that this hypotenuse has a length of 52.8 meters per second. So that is the landing speed. To turn it into a landing velocity, we also need direction. So if we're trying to find this angle right here, we'll go below the horizontal. That's pretty typical for landing velocities, right? Our angle below the x-axis. Then we're going to take the inverse tangent of 17 over 50. So remember, tangent is opposite over adjacent. 17 over 50. So we take that inverse tangent and we get that this angle must be 19 degrees below the horizontal.